Welcome back. Tonight's video is comparing real numbers. Our standard is 8EE4, compare mathematical expressions. Can we change our essential question to how can I compare and order real numbers with question mark, please? Once you got that down, you can unpause your video and we'll get started. So our Venn diagram here, which is also in our math textbook, it explains the difference between a rational number, which is on the left, and the irrational numbers, which is on the right. We've done a really good job talking about our rational numbers. Irrational numbers we've hit on here or there. So let's get some definitions going. A rational number, like we talked about last week, is a number that can be expressed as a fraction where the numerator and the denominator are integers and the denominator is never zero. So that's our terminating decimals, our repeating decimals, our whole numbers, our integers. An irrational number, and we talked about this being pi, is a number that cannot be expressed as a fraction, where the numerator and the denominator are never zero. So it's a decimal that goes on and on and on and on and on, just like pi. It never ends and it never repeats. So that's kind of easy to remember, the difference between a rational number and an irrational number. The rest of this Venn diagram, we need to kind of define a little bit more. So if you need to pause at any time, go ahead. Looking back at the left side, the rational numbers, we've got integers, which we've talked about already. Whole numbers that are either positive or negatives, no fractions. Our whole numbers we've done since kindergarten. So those are just integers, no fractions. And the natural numbers are whole numbers that are only positive. And if you see the way that this Venn diagram works, an integer can also be a whole number can also be a natural number, and a natural number is all three of them, a whole number, but it can't be an integer because it has to be positive. Okay? You got your fractions and your decimals outside of the rings because they can't be any of those things. They're just rational numbers. So when you see those, you're going to label them rational numbers. So, of course, the book is going to ask you, name all sets of numbers to which a real number belongs. So you were using those categories to name where this belongs. Rational or irrational, whole number, integers, natural, all that kind of stuff. So in example 1, we have 0.252525, which we know is a repeating decimal. A repeating decimal makes it a rational number. Then we look at the other categories. Are they whole numbers? No. Is it an integer? No. Is it a natural number? No. So rational numbers is the only thing we can write down for example 1. Square root of 49 was just in our last lesson. Square root of 49 is 7. So 7 can be what? Well, it's a rational number. It's also a whole number. It's also an integer. And because it's positive, 7, it's also a natural. So this is going to have 4 different answers or subsets to which each square root of 49 belongs. All right, square root of 12. Square root of 12, you'd probably have to use your calculator if this was asked on a homework or a test. It won't be a test because calculators won't be there. So the decimal is negative 3.46410. It goes on and on and on my calculator. So that makes it never ends and it never repeats on the calculator. So what am I writing? I was trying to write never ends, never repeats, but I'm just going to write irrational number because that's the definition of an irrational number. So I'll answer the question that way. All right. So we need to make sure we get this in our notes. So as they're asking us to compare and order real numbers, all of them, percents, decimals, fractions, they all have to get to decimals so that we can tell whether they are less than or greater than. And the ones on the assessments are going to be clear as day. They're not going to be as close as these examples. You wouldn't need to use a calculator for these examples. So here we go. We've got replace the circle with a less than, greater than, or equal sign to make 2 1/4 and square root of 5 a true statement. So 2 1/4 is 2 25/100. Square root of 5 on a calculator gives us 2.236067, on and on and on. Since 2.25 is greater than 2 and 2 0.236067, we'd have to put 2 1/4 is greater than with an inequality sign in our example. Moving on. Compare the numbers, oops, that should be a G, apologize, using less than, greater than, or equals to make the statement true. So 2 2/3 I know by heart is 2.66666666. Square root of 7 I do not know by heart. I'm going to have to check a calculator. So it's 2.46, on and on and on and on. So 2 4600 is less than 2 6700. So square root of 7 is less than 2 2/3. Moving on. 15.7% and the square root of 0.02. So I have to change the percent to a decimal. So we divide by 100, or we move the decimal place 2 to the left, which gives us 0.157 as a decimal. The square root of 0.002 is 0.14142. So it looks like 15.7% is greater than the square root of 0.02. All right, square root of 11. 3.662. There's a long one. I know this one, 3 and 3, 3, 3, 3, 3. So, ooh, this is close. 3.316 and 3.3. Either way, square root 11 is less than 3 1/3. All right, last example. Square root of 6.25 on your calculator is 2.5. 250%, decimal 2 to the left gives me 2.5. And what do you know? Square root of 6.25 is equal to 250%. Boy, do they not look equal in the first form. Moving on. Now we got to order the set of numbers from least to greatest. So first I have to change them all to decimals, and then I have to make sure, oops. So square root of 30 on a calculator gives me 5.48. 6 can stay 6. 5 4/5 is 5 8/10 if I multiply top and bottom by 2. So that's 5.8 as a decimal. And 5 3600 can stay. Now I got to put them in order from least to greatest. So you should be imagining the number line 5 to 6. The closest one to 5 would be 5.36. The next one would be square root of 30, which is 5 4800. Then we have 5 4/5, which is 5 8/10, and finally 6. All right, example 6. Square root of 5 is what? 2.236. Square root of 6 is 2.449. 2.5 can stay. 2 and 5. 5500 can stay. 7/3 is 2 1/3, so that's 2.3 repeating. So in order from least to greatest, from 2, I'm sure you love my straight lines, to 3, closest to 2 would be square root of 5 is the smallest. 2.2 is closest to 2, followed by 7/3, which is 2.3, and then it looks like square root of 6 at 2 4400, then 2.5, and 2 5500. Making sure that I get them all. Least to greatest is done. And that is it. Yes, you can use calculator when you can't figure it out. The ones on the test will be given for you. Thanks. Have a good night.